Hello and welcome back to the course on blockchain, and today we're talking about security. So we've got two topics, Ethereum virtual machine and gas. Let's see how they relate to security. Okay, so here's our system so far, our setup. We've got the blockchain, we've got the network, we've got the smart contracts, we've got the data, the transactions, we've got everything. Like you can see, this system has grown, is becoming so complex. And in complex systems, you have security threats. You have more and more opportunities for things to go wrong. And so let's start with this question. What are the most obvious, most evident security threats that might have popped up along our discussion so far? So we've already discussed one, and that one was the whole notion of loops, of why Bitcoin script never included loops, because somebody might maliciously or by accident include an infinite loop or a very heavy loop that would really slow down the computations on all of these nodes and slow down the network, and people wouldn't be happy and so on. So they didn't include loops, but Ethereum did. So we still haven't discussed how they solved that problem. How come their loops are not a potential threat? And on the other hand, a second problem that might have popped into your mind when we were discussing smart contracts is these smart contracts run on every single node, on every single machine in the network. How convenient is that for a virus? If somebody writes a virus as a smart contract and sends it out on a blockchain, gets copied to all the computers, then all of a sudden it's the end. Like everybody's machine is infected. And let alone the viruses, what if these smart contracts gain access to your private files? They're running on your machine. What if they access your files that you have on your hard drive and any, like, maybe to even your webcam and things like that? Who needs that? Why? Where's the protection from that? And so those are the two main security threats that we're going to address today. So let's outline them here. We've got viruses and access to private files, and infinite loops, or even just heavy computations. That's also sufficiently bad. So let's have a look. How these problems solved? The first problem in our list, which is the viruses, what is done about that is when you participate in the network, you actually get an Ethereum virtual machine, or otherwise EVM. So it's the first topic here in our header. And what the EVM is it's a virtual machine that is running on your computer, and therefore it completely encapsulates everything that runs there. So this smart contract, it actually runs, it is on your computer, but inside your computer, it's kind of like having a computer inside of your computer. You have that virtual machine inside your computer, and nothing can get out of that virtual machine. It's like the smart contract or any other program that's running on the virtual machine doesn't know that anything outside of that virtual machine exists. You're guaranteed that anything that happens on the virtual machine stays on the virtual machine. So if something were to go wrong, it would only go wrong inside that virtual machine, and you could just delete it off your computer. It would never actually spread onto the rest of your hard drive and all the everything else that you have on your machine. And at the same time, also what that means is because it's secluded, because it's detached from the rest of your computer, that means the smart contract will never have access to your files, to your private files, to other things that you have on your computer. It will never ever be able to see them. And so there you have that confidence and security that you're safe, that your privacy is safe. So that's how they solve that viruses and privacy issue with the Ethereum virtual machine. And now we're going to talk about the second issue of infinite loops or heavy calculations. How do they solve that? That's a tough one to solve. Well, that's where the concept of gas comes in. It's a really cool concept. In my view, it's an ingenious solution. And the solution is, for any computation that's run on the blockchain, the developers or the smart contract need to pay. Well, the smart contracts needs to pay. So you have a notion of gas, and you use that gas to pay for any calculations that you need to run. And it's like a car. For a car to run, For a car to move, it has to use gas. Same concept here. And let's have a look at some examples here. So there's a list of costs, or like a table of costs, and this is like the official information from Ethereum. So here they specify how much gas units it costs to run an operation. For example, to run an addition operation, it costs 3 units of gas. To run a multiplication operation costs 5 units of gas. It's because it's more expensive to run multiplication operation because they're more computationally heavy. To run a subtraction operation is 3 units of gas, integer division 5, and you can look through these. For example, bitwise AND operation 3, signed less than comparison 3, and so on. Get balance of the given account 400 gas, get size of accounts code 700, and so on. So what's this? Create a new account with associated code 32,000 gas. So you can see that every single operation costs gas, and these are very low level operations. So the code that you code in Solidity then gets converted to computer code, like very low level code, and then these prices are applied. And so right away you can see how that solves the problem, that if your program is too computationally heavy, or if you have an infinite loop in it, you will very quickly run out of gas and it will stop working. It will just, that's it, the end. And that means first of all, you'll run out of money, so you'll be kind of penalized for writing that code. And second is that there will be no problem in the network because it will very quickly stop. And the other thing, but like that's the solution problem, but what I really love about this whole concept is that it incentivizes people to write good code, meaning that you don't want to make your code inefficient even by a tiny little bit because it's going to cost you more. So you're going to want to write the most efficient code possible. You're going to come up with really smart solutions to the problems. And that's a great thing, because if the future of the internet is on blockchain, if the future of the world, if Web 3.0 is on the blockchain, then that means we're going to have a very efficient future. We're going to have very efficient programs running. And that's really cool, because how often do you go on a website and it takes like 5 seconds to load, or like 7 seconds to load, or you're running a program on your computer and it's just very slow and you don't see why it's so slow and it's unnecessarily slow. It's simply, a lot of the time, it's simply because people don't write efficient code. But when you have to pay for your code to run, then it's a whole different story. You're going to put in much more effort into writing efficient code. So I think it's a very smart solution like that. Then I also wanted to show you the ethgasstation.info over here. And like, I don't use this website. I'm not a developer, but if you are going to be developing things, you might want to check it out. I think what it does is it helps you estimate how much gas you're going to be paying and so on. So yeah, the point is it exists. They actually take care of their community and they make sure that you have access to information like that. And the other thing I also want to mention is that in Ethereum, you might know that they have Ether as the cryptocurrency. So why do they need gas? Why wouldn't they just use Ether to pay for the code? Well, the thing is that the price for Ether fluctuates extremely all the time. It's like up and down daily. And so if these prices were in Ether, then they would, like in dollar terms, running like a addition operation might cost like half a cent one day and cost 10 cents the other day. And so it would be very unpredictable to try to know what your running a program is going to cost. But since they price them in gas, all they need to do is set up the conversion rate between gas and Ether, and that way, as the price of Ether fluctuates, you can adjust the conversion rate between gas and Ether. And with that, I think, because again it's a distributed system, there's no central authority, the way they decided, as far as I know, is by community consensus, that conversion rate. So these are more or less fixed, and then the conversion rate between gas and Ether is decided by community consensus in some way. And yeah, so that's how the system works. And the other thing I wanted to say here is that this, now that we know the connection between gas and ether, we can see the difference between ether and Bitcoin. So the predominant idea behind Bitcoin is to create a cryptocurrency, something that people can transact with and exchange value and pay for services, and something that's borderless and transparent and stateless, and there's no restrictions. You don't have to, it's permissionless. You don't have to ask permission for people to send money wherever you like. And that's the core principle behind Bitcoin. Whereas with Ethereum, with Ether, even though people do use it to transact, people do use it to invest into, but at the same time, now that we know that it is that this whole concept of gas, Ether, the idea behind Ether is not to create a cryptocurrency, is to create a system, a network where people can run code on the blockchain and pay for it with Ether. To create a system where you can actually create applications that will run on the blockchain, and payment for those for running applications, as we saw, is absolutely necessary, because otherwise people are going to abuse the blockchain. Is going to they're not going to write efficient code and so on. So Ether is a means to create that environment where programs can be safely created and run on the blockchain, and that facilitates all the promises of Ethereum, that we're going to have all of these applications, all these programs, all of these decentralized applications, and so that we can move to a future where there are no central organizations that have the servers where everything is running. So it's just a way for all of that to happen. It wouldn't have been possible without Ether, because of that whole notion of the Turing completeness of the language. So you can see how it all ties in together. In order to have Turing completeness, you have to have a cost for these operations. Otherwise, the system's going to be abused. And that's why Ether comes in. And Ether is, therefore, not just a cryptocurrency. It's actually the means for all of this whole thing to work. So it's actually much, much more than a cryptocurrency. The foundations behind Ether are much more involved than just a means to exchange value. It's actually to facilitate, to empower this whole system. It's like the fuel, the gas. There you go, the gas that's running the whole system. And eventually, if we move to this, then it's the gas that's going to be running this whole global computer, or the next version of the internet. And to finish off, we've got some additional reading. Interesting comparison here, because the author took some operations and calculated their cost in US dollars. For instance, to add or subtract to integers, it would cost that many dollars, or for $1 you would get 37,000 subtractions. Or to add or subtract to integers 1 million times, it costs you $26.55. Well, that's at the time of writing. Of course, the prices fluctuate. But yeah, so if you're interested to learn a bit more about that, then we'll link this in the course notes. So there we go. We talked about two security problems today: viruses and access to private files, and heavy computations and infinite loops. And we saw how Ethereum solves them with the Ethereum virtual machine and the whole concept of gas. I hope you enjoyed today's tutorial, and I look forward to seeing you back here next time. Until then, enjoy blockchains.